Now we move on to Lecture 6, covering Geometry, Simplification and Repair in ANSYS Design Modeler. So here we can see in the red box where the Geometry, Simplification and Repair stage sits inside the pre-processing workflow for ANSYS Design Modeler, or the ANSYS simulation process. And it essentially sits at the back end of the pre-processing workflow just before we get to the meshing stage. So the repair and cleanup stage would be done right at the end of the as the last set of operations in terms of geometry preparation. So why do we repair geometry and how do we fix it? Well, typically when we import geometry from external CAD systems, the translation operation can result in incomplete, corrupt and disconnected geometry that needs some attention. I mentioned in an earlier lecture that Design Modeler uses the Parasolid kernel as its basis. Now, if we look at the other CAD systems available, they may not use the Parasolid kernel, and in many cases we need to translate the geometry to a form that Design Modeler can understand. And during this translation, this can result in this incomplete, corrupt geometry that needs some time in order to repair it. Now, there are two types of repair, as it were. There is the cleanup and also defeaturing. The cleanup is trying to fix the geometry, to try and connect all the disconnected geometry, to try and repair all the surfaces which or replace surfaces which may have become corrupted, either as a result of the translation or that were originally there in the first place in the CAD. And defeaturing involves removing of unnecessary details. So if we have, for example, bolt holes and threads, nameplates, embossing, all these types of features that we don't actually need for the simulation and would cause unnecessary problems, we can actually remove those using some of the defeaturing tools available in ANSYS Design Modeler. And we can also use Design Modeler to decompose the geometry or break it up into smaller meshable subsections. And this allows us to better control the mesh distribution, and also allows us to better define and manage the solver, for example, for physics for different meshable sections. So the cleanup tools can be seen under the Tools menu within Design Modeler. So if we go up to the Tools option and then down the tree, we can see we have Repair and Analysis tools. And when we click on these options, we will open up some additional tools available for repair, listed here from hard edges down to faces, and also some of the analysis tools for diagnosis of the model, from distance finder shown on the right here down to small entity search here. It may be that you need to change some of the viewing options that we described earlier for connectivity, for example, or wireframe mode for viewing in order to better understand the problem areas that need to be treated. So here's some of the typical geometry issues that we can see in this slide. So some of the issues may be missing faces, sliver faces or very sharp faces which would cause problems with meshing. Hard edges, small edges, and sharp angles. And there's some examples here which can be seen. So here we have a missing face where we have this hole in the geometry. We need to create a new face in order to fill in that hole region. We have a sliver face, which is a very thin, in this case, annular face, which is wrapping around the nose of this curved section. And we can remove that sliver face that would, again, cause problems with quality of the mesh in this region. That can be removed. Hard edges are simply single edges which extend only part way out into a face, and they're unnecessary as a feature edge, so we can actually remove those with some of the tools shown here. We can also have small edges. We can see we have a number of edges wrapping all the way around here, and some of these are very small. And because we have to place nodes, mesh nodes along these edges, and also we have to place mesh nodes at these intersection points on these vertices, this means that we could end up with some a very refined surface mesh or unsuitable surface mesh quality in this region. So we can remove some of these small edges by merging some of these edges together. And we can also replace some of these faces and remove some of these sharp angles again that would result in poor quality surface mesh. So we can remove some of these with some of the repair tools as well.